Okay, so you just watched a video about the 5 types of reactions that exist. This right here is the answers that you should have in this order. What I just want to do real quick is I would like to go through each one, show you an example, and just repeat the point that that teacher made. So the first one, synthesis. Here's an example. So magnesium oxide plus water will form a base, magnesium hydroxide. The key thing, if it's going to be a synthesis, is this right there. All right? It is only going to have one product. Okay? It can have more than 2 reactants. All right, but you have at least 2 of them coming together to make or synthesize one new product. That's the key. Now decomposition, like that teacher said, is just the opposite. So this time, instead of one product, the key thing is it has to have one reactant. Potassium carbonate will decompose and break apart. That's what decomposition means, breaking apart into potassium oxide and CO2. Now sometimes it can break apart into more than just 3 products. The key thing is, if you're going to know it's decomposition, just one reactant that breaks apart. Now this one here, single replacement, there's a couple different things that can happen with this. What'll happen is you'll have something by itself, in this case a lithium metal. It's going to kick off and replace something in a compound. Now if this is a metal, the thing it has to replace is another metal. So it's not going to kick off the NO3, it's going to kick off the Na. And so Na is by itself, and now you have LiNO3 is lithium nitrate. Okay. A different example of this, and the teacher was talking about it, he just didn't show you one, would be if I have a nonmetal that is going to replace something. In this case, my fluorine is not going to kick off and replace sodium, because fluorine's a nonmetal. It has to kick off another nonmetal. So in this case, it's going to replace the bromine. The bromine's going to be by itself as Br2. Now this is the first equation I've written that isn't balanced, so we can balance it real quick. I need 2 here and 2 there, and then that will be balanced. Okay. Now a double replacement is I'm going to have 2 compounds like this here, and they're going to switch spots, the cations to the anions. So this Ag right here is gonna, this Ag is a positive charge, so its new partner is gonna be the chloride, which is negative. Always write the cation first, Na, and Na is a +1 charge. Its new partner will be nitrate that has a -1 charge. So, like you said in the video, your anions here just switch places. Right? You're never going to have 2 positive cations come together or two negatives, make sure you have opposites coming together over here. Right? And now the last one, combustion. Right? The key thing about combustion is this, is you're burning something in the presence of oxygen, O2. Oxygen has to be one of the reactants in order for it to be a combustion. Right? So he did one where there was carbon in it, so I'll do an example of that. Let's say we burn methane gas in O2. Right? Every single time we do oxygen in one of these hydrocarbons, it's always going to end up with CO2 plus H2O as the products. This right here, that's the key thing to recognizing that it's a combustion. And this equation is not balanced. We need a 2 right there to make the hydrogens work out, and then another 2 right here. But we can also burn something that's not a gas or hydrocarbon. Let's say we wanted to burn a piece of aluminum metal. Key thing is, you know it's combustion if you have O2 in the reactants. Now it's going to form this Al2O3. Like the teacher was saying, this could also technically be called a synthesis. If you said either one, you wouldn't be wrong. The reason why it's synthesis is because it only has one product. This one here isn't balanced. I would love for you to real quick try and balance that on your own. All right. Well, this is all that I'm going to say today. Once again, who's out there getting tan right now? This guy.